Hello, math buddies! How are you today? Welcome to our mathematics class. I'm your teacher. My name is Ariel Narito, or just call me Sir A. Are you ready to listen? Today, we will talk about expressing rational numbers from fraction form to decimal form and vice versa. In this lesson, you are going to apply some concepts of fractions, decimals, and arithmetic, such as the different types of fraction and decimal, and the division concept. You have to understand and master this module, otherwise it will interfere your ability to learn the next module. I have here a learning module for you to work on this week. The module is composed of discussion and activities, but before you proceed to the lesson, you have to answer first the pretest in What I Know page. It is composed of 15 items, multiple choices. After answering, give your module to your parents or guardian for checking. They have the answer key. If you got a perfect score, you can skip the module. But if you got a wrong answer, you have to proceed with the module. Let's prepare. Are you ready and excited? From your previous lessons in your early grades, you learned about fractions, decimals, the different kinds of fractions and decimals, as well as division and multiplication. We have here three kinds of fraction. So we have your proper fraction. When we say proper fractions, these are fractions that the numerator is lesser than the denominator. So example, we have your 1/8. 1 is less than your 8, which is your numerator is lesser than your denominator. We have your improper fraction. Example, so improper fraction is the opposite of proper fraction. The numerator is greater than the denominator. So example is 6/5. 6 is larger than 5. The last kind of fraction is we have your mixed fraction. Mixed fraction is a composition of your whole number and a proper fraction. Example, we have your 5 and 3/8. Let's have some examples of fraction, then you identify what kind of fraction is being presented. So we have the examples number 1, 5/8 until number 5. Number 1, 5/8, since 5 is lesser than 8, then therefore that is a proper fraction. Number 2, 5 and 5/8. Since it is a mixture or it composed of a whole number and a proper fraction, then therefore that is your mixed fraction. Number 3, 9/8. So 9/8, since 9 is greater than 8, then therefore that is improper fraction. Number 4, 6/9, that is a proper fraction. Number 5, 21/25, that is a proper fraction. More examples are in your module. I would like you to answer it. Now, let's try to divide numbers. In dividing numbers, we have two situations. Having a quotient as an integer and quotients as not integers or decimals. Let's have an example in dividing numbers. Number 1, find 16 divided by 4. So doing the long process in dividing, we know that there are 4 4s in 16. So therefore, 16 divided by 4 is 4. For more examples of dividing numbers, you can check your module. I want you to analyze the given situation and answer what is being asked. It is in your module and you can write your answer on the given space below. From the situation that we tried to analyze, how did we come up with the answer? Or how did you come up with the answer? It's quite easy, right? But to come up with the answer, we need to express rational numbers from fraction form to decimal form. And in expressing irrational numbers from fraction form to decimal form, we have steps to follow. So first step, express the denominator of the fraction into a power of 10, 100, 1000, etc. Next, divide the fraction using the power of 10, which make the conversion then simple. It's quite easy. So let's have an example. Number 1, 3 divided by 25. We convert that one into decimal form. We need to think of a number to multiply it in the denominator, that is 25, to make it in the power of 10, 100, or 1000. So 3/25, by multiplying numerator and denominator by 4, the denominator can be made into a power of 100, 10, or 1000. The conversion to decimal is then simple. Since the new denominator of the fraction is 100, and it has 2 zeros, just move the decimal point of the numerator 2 times to your left, then therefore, the quotient is 0.12. Another example, let's have number 2. 2/5. convert that one into decimal form, you need to think again of a number that if you will multiply to 5, it will become into the power of 10, 100, or 1000. So, by multiplying numerator and denominator by 2, the denominator can be made into the power of 10. The conversion to decimal is then simple. Since the new denominator of the fraction is 10, it has 1 0. Just move the decimal point of the numerator one time to your left. So the quotient is 0.4. But what if you cannot make the denominator of the fraction into the power of 10? Just simply divide the given fraction. So let's have an example for you to visualize how to divide the given fraction. Number 1, 3 over 8. So since there is no number that if you will multiply to 8, it will become 10 or 100 or into the power of 10. So just simply divide the given fraction using your long method. So we have this one. 3 divided by 8. Doing the long method, 3 cannot be divided by 8. So therefore, you add 0. By adding 0, that will become 30 divided by 8. And 30 divided by 8, we know that there are 3 8s in 30. So it will become 3 multiplied by 8, that will be 24. And 30 subtracted by 24, it is 6. Now, 6 divided by 8, you cannot divide that one. So again, add 0. It will become 60 divided by 8. So we know that by dividing 60 by 8, we have 7 8s in 60. Again, doing the process, you need to multiply 7 by 8 to get the product of 56. We will repeat the process until we get the difference of 0. By dividing 3 by 8, we have the quotient of 0.375. Therefore, 3 over 8 is equal to the decimal 0.375. Now, for more examples in expressing a fraction form to decimal form, you can take a look at your module in the What's in It part. Now, let's try to express decimal forms to fraction form. So every rational number can be represented by either a terminating decimal or a repeating decimal. You need to take note of that one. The decimal 0.375 is called a terminating decimal because the final remainder is 0 and the division ends, which means the decimal is not continuous. The digit 4 continued to repeat without end. The decimal 0.444 is called repeating decimal. A bar or vinculum is used over the digit or block of digits that repeats. To express rational numbers from decimal form to fraction form, let's do this one step by step. So a terminating decimal can be changed to a fraction by writing the way it is being read. Let's have an example. Change 0.75 to fraction. The solution for that one, 0.75 is read as 75 hundredths or 75 over 100. Therefore, 0.75 is equal to 75 over 100. Take note that if you are expressing rational numbers from decimal form to fraction form, you need to simplify the fraction. So by simplifying 75 over 100, we have 3/4. Let's have another example. Number 2, change 1.125 thousandths to fraction. So in changing that one, 1.125 is read as 1 and 125 thousandths. Or, that is your 1 and 125 over 1,000. So, 1.125 thousandths is equal to 1 and 125 over 1,000. Since again, you need to simplify the given fraction, by simplifying that one, we have 125 over 1,000 is equal to 1/8. Combining the whole number, we have your 1 and 1/8. But if the given instruction is you need to convert that one into an improper fraction, the answer can be 9 over 8. So changing a terminating decimal is quite easy because you need to change that one the way it is being read. Now, a repeating decimal can be changed to a fraction using these steps. First, write the repeating digits only once as the numerator. Second, write as many 9s in the denominator as the number of repeating digits. Let's have an example. Express 0.4 bar as fraction. Again, doing the process or the steps, we write the digit as the numerator, then we write 9 as how many digits are there in your numerator. So since the digit is 4, we have the numerator as 4, and we write 9 because we only have one digit in your numerator. As simple as that. Let's have another example. Express 0.17 bar as a fraction. Since the repeating digits are 1 and 7 because of the bar on top, we make that as our numerator, then we write 29 as our denominator because we have two repeating digits which are 1 and 7. So the fraction form of 0.17 bar is 17 over 99. If you are having hard time on the given examples, you can check your module. There are some examples on the what's in it part. Okay? So that's how we express rational numbers from fraction form to decimal form and vice versa. It's time for you to do the activities in the next pages of this module. You may ask help from your parents, older brother, sisters, or guardian. Remember, do not miss any activity in this module. You can find the answers at the back of the module. If you got low score, go over and over your mistake and solve it again. Good luck, have fun in doing the activities.